Here is a concrete number to start with. The Linux kernel contains network drivers for hardware that hasn't shipped in over 2 decades. And right now, automated AI-driven fuzz testing tools are filing bug reports against those drivers at a rate that is genuinely overwhelming the humans who maintain upstream kernel development. This is not a story about AI being bad or good. It is a story about a real operational bottleneck inside one of the most critical software projects on the planet, and it has a specific, traceable cause. Let's establish what's actually happening. Fuzzing has been a standard kernel hardening technique for years. Google's syscaller, for instance, has been running against the kernel since around 2016 and has found thousands of real bugs. That's legitimate and valuable work. The problem being discussed now is a newer layer on top of that. AI-assisted or AI-driven bug detection pipelines that are generating reports at a volume and targeting a scope that the existing maintainer bandwidth cannot absorb. When those reports land on drivers for, say, a PCMCIA Ethernet card from 1998 or an ISA token ring adapter that hasn't been in production hardware since before most current engineers started their careers, you have a resource allocation crisis dressed up as a quality improvement initiative. The specific concern being raised by kernel maintainers is this: the signal-to-noise ratio on incoming bug reports has degraded because the tooling doesn't filter by, does this driver have any plausible real-world users? A fuzzer or an AI-assisted analysis pipeline doesn't know or care whether the code path it's hammering corresponds to hardware you can actually buy, find on eBay, or encounter in any production environment. It just sees code and it finds potential issues in that code, and it files a report. From a pure coverage standpoint, that's correct behavior. From a maintainer workload standpoint, it means people who are volunteering their time or being paid by companies like Intel, Red Hat, or Google to work on upstream kernel development are now triaging reports for hardware that almost certainly has zero active users. The response being floated is significant, actually removing some of these old network drivers from the kernel tree. That's a meaningful technical and governance decision, not a minor cleanup. The kernel has historically been extremely conservative about removing code. Linus Torvalds and the broader maintainer community have generally held the line on not breaking user space, which in practice means not removing drivers that someone, somewhere, might conceivably be running. The fact that this conversation is now happening at all tells you something about how bad the noise problem has gotten. To be precise about what removal would mean operationally, if you are running a modern distribution on modern hardware, this affects you approximately zero. These are legacy drivers for legacy hardware. If you are somehow running a production system on a machine with one of these NICs, first of all, that's a fascinating infrastructure conversation. And second, you would likely be on a long-term stable kernel branch anyway, where these drivers would persist for the foreseeable future. The LTS kernel model means removal from mainline doesn't equal immediate disappearance from all supported trees. But here's the part that actually matters for anyone thinking about upstream kernel health as an infrastructure dependency. This situation is a symptom of a structural problem that isn't going away. The volume of automated bug reports is going to keep increasing. The tools are getting better at finding potential issues, not better at prioritizing them by actual risk or actual deployment relevance. And maintainer bandwidth is not scaling at the same rate. There are roughly 1,000 active kernel maintainers, depending on how you count, and the kernel has around 30 million lines of code. Adding AI-generated noise on top of that math is not neutral. There's also a subtler issue worth naming. When maintainers are spending time triaging low-value reports on dead code, they are not reviewing patches for active subsystems, not mentoring new contributors, not working on the security-relevant drivers that are in every cloud VM and every container host running right now. The opportunity cost is real even if it's hard to measure directly. Kernel development velocity is already a concern the industry has discussed for years, specifically around the difficulty of getting patches reviewed and merged in a reasonable timeframe. This makes that worse. Now, to be fair about what's unclear from the reporting, we don't have precise numbers on how many reports per month are coming in that fit this profile, which specific drivers are being targeted for removal, or what the formal governance process looks like for actually pulling them. 4Nix is covering the discussion, but the discussion is still early. No specific removal patch series has been widely circulated as of this reporting. So the Linux may drop old drivers framing is accurate in the sense that this is being actively discussed by people with the authority to make it happen, but it's not a done decision with a timeline. What is clear is the mechanism. AI and fuzzing tools that don't incorporate deployment context are creating a tragedy of the commons problem for shared infrastructure. Every individual tool that files a report is doing what it's supposed to do. The aggregate effect is degraded capacity for the humans maintaining code that actually matters. For anyone running internal security scanning or contributing to open-source projects, this is worth internalizing as a design principle. Automated bug-finding pipelines should have some model of deployment relevance built in, or at minimum, they should not route low-confidence reports on unmaintained or legacy code directly to human review queues without a triage layer. Filing a bug is not free. The cost is just externalized onto the maintainer. If your organization uses tools like syscaller, CodeQL, or any AI-assisted static analysis pipeline against open-source dependencies you contribute to upstream, the practical action here is to audit where your reports are going and whether your tooling has any mechanism for filtering by code age, last commit date, or known deployment surface. If it doesn't, you may be contributing to exactly this problem in whatever open-source projects your team participates in. That's a configuration decision you can actually make. The real story underneath the headline is simple. Automated tooling has scaled faster than human review capacity, and the kernel community is now considering irreversible architectural changes to the codebase as a defensive response to that imbalance. That's not an AI story. That's a systems design story about what happens when you optimize one part of a pipeline without accounting for the bottleneck downstream.